Yankin, apologies, Yankin. I forgot to turn on my Zoom. My goodness. Can you hear me?
Yeah.
Can you hear me now?
Yeah.
All right. Sorry. I forgot to turn on my Zoom. Right.
That's fine.
Okay. Right. I can see your video. Very nice. All right. So I better wait a minute. Okay. Sorry. You prepare your stuff first.
Yep, give me a sec.
Mhm. Yeah, I think I have an error and I'm going to ignore that. Right. Just, yep. You good? Please give me some updates.
Okay. Well, since Monday, we did camp the periodic table.
Right. Okay. Mhm.
Yeah. So my teacher went through like all the stuff that I highlighted on Monday. So like the hydrolysis stuff. So I know better what it is about now.
Hydrolysis. Sorry. Why do you mention hydrolysis? Sorry.
Oh, when we were doing the question mark stuff.
The Aryan question.
No. The question, like these kind of question marks and like these.
You're talking about hydrolysis. Wait, sorry. Right. So I believe you did not read. So did you read until here? Sorry. I forgot that. Oh, you did. Right. Okay,
Yeah.
good. Yeah.
Anyways,
Okay, yeah.
my teacher reached hydrolysis today. So yeah, I guess that's a good estimation.
I suppose you prepared slightly more, right? Something like that.
Yeah. Yeah. And we did math also.
Right.
We didn't do the differential equations. We started on definite integrals. Like not really started. We just revised area under graph from O levels.
Yes. And so you have not done the differential. Sorry, let me confirm. You have not done.
Yeah.
It'll be later.
I think we'll finish differential. Definite integrals first before we do
Very
differential
soon.
equation.
Very soon. Perhaps in 2 sessions at most. 2 sessions. Good.
It's very thick, this one.
It's not as complicated. Yeah. Okay. Understood. Then what else?
No physics. So physics is tomorrow.
Oh, no physics in these 2 days, really?
Let me check my phone.
I thought there is one, right?
Give me a second. I don't think there was. Let me check. Yeah. Yeah, no, my first physics lesson was on Monday.
Which we kind of went that, right? Okay.
Yeah. Then the next one is tomorrow.
Good. Right. Okay. Let's talk about your preparation. So the preparation that kind of hit the spot is chemistry, right? And you prepare for a grand total of basically 12 minutes, I suppose, right?
Yeah, so that's like an hour of the lecture.
And to cover, which is by the way expected. Yeah, it is expected that that's the amount, the time of preparation that you will need to do for every 1 hour of lesson, and that is assuming that it is a 4-star or 2.5 star. That's really enough. Now, how do you feel? What do you think
about the preparation
and how it affects, your understanding, I suppose?
Yeah, I mean, I guess I paid more attention during that part because I already knew what they were going to talk about. Like kind of knew, not completely.
Yep, of course.
Other than that, just seems like it's okay, pretty good.
Right. Think about it, when you are having the lecture, right? What is the star? Because I don't know what's the slot.
Lecture,
Back then,
let's say
chemistry slot, right?
like probably 3. I was in a lecture hall and everything, and like the teacher, it was like a small lecture hall as well, so the teacher could see everyone. So,
Right.
like,
okay.
Yeah, 3.
Right. So 3-star is not bad for the school time. I mean, there are 2 stars, right? There are 2 stars.
Yeah, like in like 4 to 5, I was totally wiped out. I have no idea what's going on then.
Right. Which is something we can salvage, but later. Okay. I'm happy that we are, improving the 3-star. But if you think about it carefully, did the preparation improve the 3-star, or is it because it is 3-star that it is you have better understanding, right?
I mean, I went in like at least knowing what I feel like the teacher is gonna talk about, so that might have helped.
All right.
Like looking ahead kind of things, and
right.
Like tomorrow we're gonna continue different integrals for math, so
that's a good prepare, right? Very good thing.
Yeah.
So you are not disturbed. Are you comfortable with your questions in the lecture hall?
Kind of, cause like I didn't ask any questions, but she did highlight some parts that I like pointed out in my preparation, like hydrolyze slightly, hydrolyze slightly as opposed to like hydrolyze completely means that it can be a reversible reaction, all that stuff. So like
it should be, by the way, it should be a reversible reaction. Yes.
Yeah, like I didn't know that, but like I didn't know it like before I came in, but I pointed out that I didn't understand what hydrolyze slightly means, so I guess it helps.
Right. Okay. What else? What else can did the teacher cover something that you miss? Miss meaning not that you don't understand, but you don't even realize that it is going to be covered. And did that happen? Like you basically miss a question mark, basically. Did you miss a question mark? Do you think?
Let me see. I think, was it the pH?
Right.
I think I started doing pH, but I didn't see that one at all.
Right. Okay. Okay. So you will say that perhaps roughly, the preparation seems to be useful.
Yeah, I mean, for a lot of time I spent on it, which is not a lot, I guess.
Right.
But like,
and I don't expect
that I'll ask like, I don't expect that I'll like prepare like proper questions every single time, but I guess I can try.
Yeah, I don't mean that you should spend more time. I don't think you can spend less time also, but 10 minutes is reasonable. And I don't think you should prepare a question in the sense of construct a question, I suppose, but question marks are the minimum, I suppose. Yeah, I suppose. Because the question marks are very specific, and I see that you don't write anything or erase anything. Do you think that the question marks are basically answered?
I mean,
all of them?
I mean, like, I put that up because I like the specific question, because I was like generally unsure like what it meant. So I guess it kind of fulfilled it.
Right. I suppose, yeah, which is is it something suitable for you to not write things down, which basically means you're paying attention? I mean, it can only mean 2 things, right? Either you're paying attention so you don't write things down, which is not bad, or you do not know what's going on. So what do I write, right? I suppose, right? Which one is it, do you think?
I mean, I hope it's the former, but
you can trust your feeling. You don't have to you don't have to discount your feeling. So how does it feel?
It feels like I'm paying attention more.
Right.
I should probably still write some stuff down,
That one is a subject of your self-knowledge. Do you write or do you not write? if you are
down,
paying attention, right? If you are paying attention.
I write stuff down during math, like math lectures.
And in chemistry, like, things can be different. Like what are you?
I mean, like this is the first. I think like this is one of the first few chem lectures I had. Like it's like
you feel bright.
No. This is the first one of the first few chem lectures I had on site. Like since I started JC.
I don't get that part. Sorry, what do you mean by that? So how can this be the first few?
Because like all the chem lectures so far have been online,
recorded.
Yeah.
Oh, are you sure the improvement is not because of it's an on-site thingy, live thingy instead of recording thingy?
Yeah, I don't know.
In any case, you probably will continue preparing, I suppose.
Yeah.
All right. Fair enough. So the expectation, you know how to prepare. There isn't much thing to it besides to do it at the right timing. That's really all. You can even prepare one lesson before, but that means you're studying something else on the appropriate lesson, which is probably one way to salvage a 2-star thing. But I think that's a fringe thingy. That's not the real thing to do. And it's not good to pick in a 2-star slot anyway, right? It's not, right? So I think that's only for very special cases. Right? Okay.
Yeah.
So glad that you're happy with it and glad that you're looking forward to it. Now, are you sure you don't want to clarify anything with me? Just up to where, your teacher teaches. Just up to there.
I think we got, this is the first we got there. PCL 5 and SICL 4.
Right. Which one? Sorry, which one?
Like here.
Here. Okay. What do you want to clarify?
Did I write it down here or did I mind?
Like you should also put in the question marks that happen in the lecture, That is the minimum writing you should do. Do you understand? If you don't write anything and you're paying attention and you're noticing questions, you should simply put the question marks, right? That's the easiest way to do it, right?
I guess so.
Yeah, you should be paying attention to your questions more than your answers. You don't have much answers yet, so to speak. Okay. You're saying that there is an unresolved question.
Maybe.
Oh, right.
Okay. Give me a moment. Let me look right back. I think that was a piece of paper.
Why is it very difficult to
Well, I mean, I was gonna pause this stuff up, but I got back and I was very tired. So back here. I just let me see. A bunch of equations. Can I find this there? Yeah, I can. Let me this down. What's it to do with? Was it with the H plus?
Sorry. I need you to ask a proper question. I need to ask what is the question? Sorry, what is the question?
Oh, I think I was writing down because my teacher write down equations here, right?
Right.
So maybe just the proper page.
Yeah. Move it up a bit. Everything move up a bit. No. I mean, what you want me to see, you move it up.
Oh.
You don't have question on MGCL2 and ALCL. No. Yes.
Kind of. I guess they're kind of related. So I don't know if you can see it.
Question is right. Your question is.
Okay. So here they're talking about H3O plus, right? Yeah, then like H2O plus here as well, and then like yeah, that's it. But then my teacher said that you can also write like H plus.
Yes, yes.
Like I don't get why you.
Right.
I guess I don't get why you can. Like,
Right. So basically, your question is, how can H plus and H3O plus be the same?
yeah, I guess.
Okay. So the physics part of it, this is chemistry, I know, but the physics part of it is that H plus does not exist by itself, or rather does not fly in the solution by itself, because H plus, you think very carefully, is just a proton.
Yeah, I get. Oh yeah.
Because a H is one proton and one electron. There isn't even any neutron, right? You take away the electron, you're left with one proton. One proton is very, 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 very small compared to a molecule, for example, right? Okay, so the physics goes that to keep it the simplest way possible, this is not very correct, but it has to hitch a place, and the best place to hitch a height, so to speak, is to attach itself to a H2O. So you have H3O plus, but H3O plus is simply H2O with one proton, basically. Okay. So that's how you will understand H3O plus. It's not some fancy thing that you can draw. It's very difficult to draw, by the way, but it is basically H2O with a proton hitchhiking. The proton in question is H plus, because H plus is proton. Proton is H plus. What else is it going to be, so to speak? So far, so good?
Yeah.
So H plus is special. Nobody becomes a charged particle, an ion, and then suddenly, oh, you're just a proton, really? That doesn't happen a lot. Right? Now, to answer your question, you would notice that in the reversible equation, right? In the reversible equation reaction, where you have H3O plus, you basically have H2O on the left-hand side. So you have H2O on the left-hand side, and you have in the reaction, reversible reaction, where there is only H plus, you do not have H2O on the left-hand side, which is what your teacher is writing, right?
Oh.
Right.
Okay.
That's the one way to make sense of this is very simple. It's just saying, okay, you know what? On the left-hand side, on the right-hand side, you both have H2O. One simple H2O, one H2O hitchhiked by a proton. So you can actually also just take away the H2O from both sides, not just from one side. Make no mistake. Okay. Either, okay, can make sense? Either you have at both or you don't have at all, so to speak.
Okay.
This doesn't happen every time, but it is obvious when you can apply it. Yeah. For example, when you look at the Mg, when the Mg1, you obviously can see H2O on the left-hand side and H3O plus. Or you can apply that low. I'm very lazy. Let me just take away the H2O. Yeah, no problem. Nobody's going to penalize you for that.
Right. Okay.
Yeah. Nor should you be confused when an exam question writes it down this way. It should not be confusing at all. Okay.
All right. Okay.
Any other question?
That's like the only new thing. But I think the rest is like atomic structure or like chem bond. Wait, give me a sec.
Is back to VSEPR lah. Yeah, back to your molecular shapes.
Okay. I think we went through like this question.
Okay, ask you a bit. This question, is it tutorial or not? This is considered.
Oh, this is tutorial, but the teacher wanted to go straight to explain something, which I did not.
Okay, tell me how does the on-site class work now? So you have a lecture, right? Which is what you say. I prepare for the lecture, but suddenly you're discussing tutorial. Is it because there is a tutorial class?
I mean, like, I don't know how it functions. There's like a tutorial class tomorrow as well.
So your teacher discussed this in the lecture or in the tutorial?
This one is the lecture.
Okay, so the lecturer take the liberty of discussing a tutorial question, which I am guessing your lecturer and your tutor is the same person.
Yeah.
So the timing is flexible.
Yeah.
Okay, fair. Okay, understand. And this periodic table tutorial is the chapter. Okay, your question is, sorry.
Okay. this question, yeah, no, I don't know.
Right. So you take note that you do not understand the teacher's whatever he's saying, right?
Yeah, may I draw like all this stuff? Then like
yeah. Like, are you sure that you don't understand anything? Because your question is very like, I don't understand. Ding, you know.
I mean,
What is it that you don't
maybe
understand?
kind of like I know that I think I know that like argon is monoatomic, meaning it cannot like bond with another element. And like
Wait. Again, Yankin, at this stage, especially at the stage where we are still learning all the basics of this chapter, for example, you should be very aware of your question. I'm not saying that what you know doesn't matter. What you know matters, really. But you are describing what you know instead of what your question is. I want you to chase your question mark rather aggressively. What is it that you don't understand instead of what is it that you understand?
Okay.
In exam is totally different. Let me just state this. In the exam, you have to chase after what you know instead of what you don't know. But I noticed that some students totally get it upside down. During learning, they focus on what they understand. During exam, they focus on what they don't understand. That's disastrous, usually. If that describes you, totally swap it. I really mean like aggressively focus on what you don't understand in learning period and aggressively make use of what you understand during exam.
Okay.
Okay. So now, don't describe to me what you understand. I think that's important, but describe to me what you don't understand. What is it?
Don't understand.
What is your question?
I guess I don't understand how the van der Waals radius differs from like something like atomic radii or like, you know.
Fair in the context of argon and chlorine, right? I suppose.
Yeah.
Right? I don't think you will be surprised that chlorine is drawn as overlap, right?
Yeah, Cl2.
Right. So when you have the how do I say this? When they say radius of sorry. Okay. Put it this way. So when they talk about van der Waals radius, they are usually talking about a molecule. Argon is not a molecule. Argon, is just a monoatomic stuff. Chlorine is a molecule. Fair enough?
Yep.
Right. So let's say you have an atom of chlorine, which in all practical purposes does not exist. Do you understand? An atomic chlorine does not exist because he will really prefer to be in a molecular chlorine, a diatomic. Right? Because sharing stuff like unhappy, right? But if we can conceptualize that atomic chlorine, you can appreciate this lah, that the molecular width is not 2 times the atomic width. It's not. It's smaller because of the overlap. Because of that, simple, right? Simple to understand. And you need the overlap because that is basically the physically describing the I am overlapping your electron with me. It is basically that, right? So you mean that. So when they say the van der Waals radius of chlorine, he takes the molecular width divided by 2. Ta-da. Wait. I didn't get it. Oh, no, I'm sorry.
No.
I'm sorry. That's the wrong definition of van der Waals radius. Sorry. The point is, the atomic radius and the van der Waals radius is affected by overlap. I mean, that's all I want to say. Whatever the definition of van der Waals radius, if you look at it, the overlap will affect that, will make it different or the same compared to an atomic radius.
So that's for chlorine.
It did not answer your question, right?
I got you up to the point of like the van der Waals is not double the atomic radii of chlorine. Okay.
Okay, let's go to the, I suppose, because we have to talk about the definition, let's go to the definition of van der Waals radius. What is it actually? I suppose we have to, I suppose we have to know that first. What's the agreement here? What are we talking about here? Right?
Van der Waals.
If you don't know, the fastest way is not to look at your lecture note.
Is to Google.
Unless you already know what it is. The fastest is to Google, right? Just go, right?
It's defined as half the closest distance of two equal non-covalently bonded atoms. That's.
Sorry, could you repeat again? The closest distance between?
Closest as half the closest distance yes. Of two equal non-covalently bonded atoms.
I'll check it out one more time. That doesn't make sense. I'll check it out, okay? I'll check it out and I'll get back to you like today, okay?
Yeah. Maybe the first response was wrong. I do that sometimes.
Yeah, I'll check it out. Yeah, let's not waste time. Any other question?
No, I think the rest was like pretty self-explanatory.
Right. So we should talk about the preparation because there's nothing urgent, right? We can talk about preparation, right?
For chem?
No. For considering your 3 subjects, right? Timing is important. Preparation is timing. You do it before the class. If you haven't do it before the class, then you don't have preparation. Simple, okay? Just do it. So considering tomorrow is I'm losing track of days. Thursday and Friday, right? Thursday, Friday, right? And usually I will say Monday. Usually, right? So you'll prepare for Thursday, and then for Friday, and then at Sunday you'll prepare for Monday. Okay, let's focus on Thursday and Friday first, right? So on Thursday and Friday, you have a chem lecture. Is that what you're saying, right?
No, I have math lecture.
You have math lecture. You have math lecture. You have physics lecture, right? You have math lecture, physics lecture,
no, physics practical.
Yeah, sometimes they focus on practicals, right? Okay.
So I guess practical and math, physics practical and math lecture tomorrow. I think all physics lectures are still online.
So are you supposed to do it? If you're supposed to do it, then you prepare for it, right?
Yeah, I guess I'm supposed to do it.
Tomorrow.
Yeah, that's what it says. Lecture 1.
So online or recorded classes, timing, it should be treated the same as on-site classes, right? There should be no difference. The preparation is all the same. Okay, Ken?
Right.
Okay. So unless you don't have a lecture note, then we have some trouble preparing effectively. So you should be preparing for physics lecture. You should be preparing for math lecture. I'm not sure what practical goes, so I don't know. And then you will have chemistry tutorial, right? On Friday.
But the chemistry tutorial, let me just check. What's the schedule for that? I know that tomorrow is a test, just like welcome back to school test.
Okay, for you, what for chemistry is it?
Yeah, for chem.
Okay, sure.
Let me just see. So tomorrow is the test, and Friday is the next tutorial, I guess. So like
right, the chem tutorial, right? So chem lecture, physics, math lecture, physics lecture, chem tutorial.
No physics practical.
And physics practical.
But like the lecture's online, so yeah.
Yeah. Or then you have a physics lecture and a physics practical lecture. Is that what you're saying?
Just physics practical.
All right. So physics practical lecture lah. That's basic. Okay. And okay, good.
And like math, which I know is tomorrow.
Right. So at this point, you will prepare your definite integral, I suppose, right? Prepare your definite integral. And then is it possible to prepare for your physics practical before watching the video, I suppose?
Well, physics practical on site, I think. I have the
On-site.
paper with me. I have the paper with me now.
Good. Let's prepare for that. Let's prepare for it. Right? So you have 10 minutes for definite integral. You have 10 minutes for and you have question mark. And I think I want to answer. I think just a little bit.
Sorry, I didn't catch that part.
Question marks for definite integral, question marks for the practical, 10 minutes each.
Okay.
Okay. I'll set the timer roughly like this. Okay. And then maybe we'll answer questions. Be very aware of your questions. Go and figure out the van der Waals and yeah, it's not very difficult to understand. Yeah. That is what I understood. So how come the question phrase it like that? Okay. Maybe the issue is That's not consistent. Yep, that's not consistent at all. But you can divide it. This is not to put pressure, yeah. I'm just saying that you have 2 minutes left. And
what?
Yeah, and I think math should be considered a slower subject to prepare because reading itself is already takes
challenging.
more. Yeah, you should expect that. That's just normal. Normal. Not many people have the opposite experience. Eh? So just it's normal. Right? It's normal. So you cannot hear my alarm, but that was 10 minutes, right?
Oh.
No pressure, no pressure, no pressure. Please, please. There is no pressure. When learning difficult stuff, the last thing you want is pressure, especially during a prime time. Right? Now, I'm saying that obviously you don't get to the point where you expect your lecturer to be, right? Whereas previously 10 minutes around there, you, I think, safely get to that point, right? Right, fair enough, yeah? So you shall not rush your preparation. You shall be very aware of your question mark. You shall have another 10 minutes. So let's say, for math, you prepare for 20 minutes for one class, okay? Okay, so another 10 minutes, right? Another 10 minutes, let's see what happens, okay?
Okay.
Unless you want to ask your question first, also can.
Nah, I only got one. I only got one of them.
All right, so another 10 minutes. Then we really stop lah. Okay?
Right. Okay.
Right. I'll take some drink.
Yeah.
Yankin, are you there? Oh.
Yeah.
All right, sorry. No, I thought you were not there.
Oh no. Ugh.
And yeah, okay, yeah. Was waiting for that, right? Yeah, was waiting for it.
Oh god, it's like a big kid.
Are you sure you're not overshooting what will be covered?
I don't know. See, my thinking is that because a lot of this is O-level stuff, the teacher will be like, this is fine, just get away quickly, you know.
Fine, but you are no longer at the O-level side because this is a, oh, it is still area of a region. Oh my goodness.
Yeah.
When are we going to arrive at the revolution thingy? There you go. We have a revolution. Right.
I just took a bunch of pages. Okay, here we go.
It's perfectly fine. Okay, I'm gonna pause the alarm for. Sorry, I'm gonna pause the alarm for. Okay, you still have 3 minutes, so again, no pressure, right? But do you notice that you don't have to read everything?
Yeah.
And understand everything? I would say that you should not revert to that mode. I'm not saying that you should jump haphazardly, but you want to be very aware of the questions that you will have, right? And you know that in in A level, they will not ask so much question about the area under the graph.
Yeah.
So if you're already confident with it, maybe you are. And if the lecturer is making it more complicated than it seems, in a very abstract way, by the way, not in a way that you do this question, you do that question, right? Then maybe you should just spend more time reading the new stuff or the work example. I think that's more beneficial than reading the abstract part. I feel like.
Right.
That's already something you decide during preparation. This thing, after reading, I'm not getting much anyway, right? There is no question mark, there's no new knowledge. Okay, I'm going to skip that. Just pay a bit attention at class just to make sure I don't miss anything. Maybe I'll focus on the example. Maybe I'll jump right to the revolution thing. Maybe you should probably do that. That's not a bad decision, right? It's a hit and miss, yeah. It's a hit and miss, yeah. But I'm saying that sciences is not strictly linear. I don't know how to describe it better. It is not linear one. It is not linear at all. You don't go from this point, then read this page and then read this page, and you expect a linear progress. That's hardly the case actually.
Right. Okay.
Okay. If you want to jump or you want to skip certain things, that's not a bad thing. Please do.
Okay. I think I will then. But like, here's what I'm thinking, right? Yeah. Like I'm doing this because like the lecture is tomorrow, so I like going with like the knowledge in my head already, right? But if I prepare for this now, which is probably gonna be like in lecture 2, which is next week, then
that's the guess, right? Okay, that'll be the guess, right?
Yeah.
Then my suggestion is this. Of course, we're making guesses. We're guessing what the class will be. It may be as what you say, right? It may be totally possible. We cannot spend too much time guessing. If you're doing something old, which is of course needed for something new, why don't you spend more time on the work example or on the self-directed example? You understand what I'm saying? Maybe you should spend time more on that, which will net you more relevant questions. Does it make sense? Yeah, this work example, or there's some self-directed learning just now. For example, this one, right? Doing it or learning the work example also may give you question marks. You're focusing on your question marks, not just one, right? Make sense? Make sense? Anyway, work examples are less abstract by right lah, right? Correct or not?
Right.
Okay, so please try that. Please try that. Again, we're chasing after question marks, right?
Okay. Point of intersection. Y point of intersection.
I'm gonna stop. Anyway, time is almost up, right? I will try to improve with you the way you prepare for math lecture. Okay. Let's start from this. Let's start from this one example, and please zoom in. Yeah, please zoom in. Good. Okay. Right. Let me confirm a few things for you. This has an O-level field.
Yep, definitely.
Okay. I give a lot of time for reading a question. If this is an exam, I feel that the way you read the question is already taking a bit too long. I'm curious why. I'm really curious. It's as if you are not engaging with the question. Like there's a disconnect. That's what I feel. First thing first, right? Second, I noticed that you asked why points of intersection, right? You did ask that. But you hang around for another 1 minute without much progress. Whereas the progress at this point simply is, oh, I have a question mark, boom. No need to spend 1 minute thinking about the answer. That is not necessarily the point. Let me give you a few alternatives. Okay, again, put the question mark first, please. Put the question mark first. You have a question mark, and it is a very good question. Why points of intersection? I don't think I will do that. That's what you're saying, right?
Yeah.
Nevertheless, you know how to find the points of intersection if you have to. It's just that you don't know why, right? So it's a question of why, not a question of how to do it. How I can, right? So I will give you some alternative. Notice what they use it for. Notice what they use it for. You try to find the why at the totally wrong place and you hang around for 1 minute. I object to your method of spending your time. I totally object. The why probably can be found on top or below. Notice where they use the 1 and -1. And you're not aiming, that's not how they use it. They just use it. They're just labeling the 1 and the -1 in the graph. That's not what they use it for. What do they use it for?
Separate the curve.
Dang it, you. Look at the integrals. Look at the integrals.
Yeah.
Yeah, the next step. The next step after the point intersection is that, not the drawing. The drawing is there to help. True enough. Do you notice how they use the -1 and 1? If they use them now. Yeah, there. Right?
So
there.
The area they're calculating there is
okay. All right. Not exactly, but you're getting close. You're getting close.
So half 2 times 2. It will be this triangle here.
Yep, that's easy to figure out. Yeah, that's true. That's true.
Then this minus this will just give you the shaded portion.
Okay. Okay. Did you answer your why already?
Yeah.
If you have not, put a question mark and then go forward. You're focusing too much on understanding something before the lecture. Too much time. You're treating this like something that you do after the lecture. Hey, I'm supposed to understand this. How come I don't understand? And you get stuck here, spending time, valuable time. I totally object on that. That's not the way to do it. You either find the answer at the lecture or you don't. Not after lecture and not before lecture. If not, why attend lecture? Just don't attend lecture lah. Just figure it out by yourself. You at least have more time to figure out yourself. You attend the lecture to get answer, right? You prepare to get your question. After lecture, you should be doing tutorial, not understanding the lecture.
Okay.
I'll be very strict here. Yeah, you're focusing too much on, I should be understanding this. How come I'm not? Well, I mean, unless the lecture is a very bad lecture or the lecture skips work example 12, I hope not, right? I hope the lecture is not that bad. You should be able to get your answers there.
Okay.
Right now, actually, after you consider how the 1 and -1 is used, because I tell you, I think you should look at the next step. The next step, I don't think is the picture. The picture is like the one helping us to understand. The next step is definitely the integration. Do you still have that question mark? Like, hey, why?
Probably
yeah?
not.
Probably not. Are you sure it's answered already?
I think so.
Is it surprising that the points of intersection becomes the limit of the integration? Is it surprising?
No, because it's like the region is enclosed by the curve and the line. So I suppose to find the region enclosed, you need the point where the curve and the line like sort of meet, because that's like the edges of the shape, you know.
Right. Are you happy with your understanding?
I think so.
Right. If you now you can cancel the question mark, you know, by crossing it or whatever lah. If you're happy lah. And it is nicer to cross than to erase, I feel, because you are reminded that, oh, back then I asked this question back then, right? 3 months from now, if I still ask the question, I should be a bit worried, right? I should be, but maybe not. Maybe you won't be doing that. Maybe you'll be fine. Okay. So I'm putting pressure on certain things that are object out of you. The way you hang around too long in a preparation stage, the way that you're not satisfied with your question, and the way that you try to find the answer in, I think in not the best way. I think you can find it on the bottom, or if you really want the answer, I feel. Again, the motivation of doing this step is usually not found on the step, if that makes sense. The motivation will be found before that step or after that step, if that makes sense.
Okay. Yeah.
That is a general thing that happens in math. The point of this step is, what's the point again? Oh, let me see on top. Let me see on top. Okay. Okay.
All right.
Okay. Try one more work example, and I want to see how you either produce questions or find answers to those questions.
Points of intersection again. Assume it's the same process, just like flipped. So y squared equals 4x. Then x equals.
Okay, I'm going to stop you there. I object on something else again. I think I will be objecting a lot on the how you study math, right? This is something that I never tried to do last year, correct? Because I never tried to see how you approach math, right? Once I see it this way, I do have a lot of objection and therefore opportunity for you to improve. Now, I want you to question the phrase without the use of a calculator. Right? I want you to question that, right? Okay. What kind of questions you have with this phrase?
I assume graphic calculator. So.
Yep. I mean any calculator because the use of a calculator, right? So no graphing calculator, no normal calculator, no whatever. You don't seem to have a question.
My first guess is like. I guess my first guess why cannot be like. Cause they don't like I guess you could
no. You're giving an answer. My question to you is, you don't have a question on that phrase.
why not? why cannot use calculator, I guess?
No, I don't think that's the right question. Seriously, that's not the right question. That totally affects your learning. I think you should actually grab your calculator. I say this to you 5, 6, 7 times, to you and sometimes to Austin last year. You still haven't learned something about it. I think that's bad. I think that's really bad. I think you should take the calculator, your graphing calculator, and draw something. Then they even give the drawing space on the left, And I noticed that you don't put the question mark, even though you must be asking that, Hey,
I assume it's just for like example, right? They won't give that during the actual question.
And let me ask you that if they don't give you this space, that means you won't be relying on any sort of picture, I suppose.
I mean, I probably would just draw it myself.
If you're going to draw it yourself, why don't you? In a sense that, should you draw it after you read the steps, or should you draw it before reading the steps?
That would be attempting the question, and like probably shouldn't do that.
What do you mean? Sorry, what do you mean?
Like that would be like attempting the question, wouldn't it?
You mean at this stage you shouldn't attempt the question?
I mean that's why I feel. That's I got from like.
Okay, let me ask you another question then. Yeah, we are trying to produce high quality questions, right? That's our preparation. Huh? If the picture is there, would you get higher quality question, or if the picture is not there, you will get high quality question? Which one in this case?
I guess the picture was there because I can visualize it.
Then you will get probably higher quality question, or maybe some sort of better understanding rather than guessing, right? Then please do that. Please do that. I don't think this is about attempting or not attempting. This is about getting better questions. You should do that.
Right. Let me get my. Oh, this is here. See, first one is y equals, no, I can't do that, right? Y equals to root 4 x two. X1 is y equals to 2x. So I guess it'll be something like this.
I cannot see your calculator, right? Doesn't matter. You did plot both at the same axis, right? Right? So the intersection is a real thing, right? Correct?
I need to redo the straight line.
I suppose. Again, let me confirm that your calculator plot them on the same axis, yeah? You don't plot them.
Yeah.
Okay, yeah. Are you happy enough with the visualizing?
This part could be better, but
Yeah,
you can.
Okay, so then again back to generating quality questions, right?
So area enclosed by. So the area enclosed would be this section, right? But like, wouldn't the area under this graph be, for example, if we're looking at from this perspective, wouldn't area, let's give a random one, would the area under the graph be like this portion? And like,
you're basing it on the y-axis, not the x-axis, lah.
That I feel, yeah.
Look, is the area of region enclosed? Are you sure you're reading the question properly? Find the area region enclosed. by the parabola and the line. I don't see you do that, you know. I don't see you do that yet. At least I don't think so.
Because I thought like obviously it's like here, right? Like this one.
Yep, and that's fine. That's yeah, you're correct. It is obvious, correct. You have some concerns, right?
Yeah,
Can you note the question? Can you note your question? Can you be comfortable with your question? Your question is
I don't know what the
describe
question.
it.
I don't know. Like, eh,
Describe it to yourself. What is your question? What bothers you? What bothers you? What is it?
I don't.
What bothers you?
I mean, like, if we're looking at it from like, nah, never mind, never mind. I can
what
just
bothers you, Yankin? What bothers? I'm serious. As what?
I mean,
bothers
shouldn't it be like this? Seeing as we're doing all, I know it's like no point, right? Seeing as this is stuff that just work for me. But like, if they're doing all this x equals to y plus 4, I'm assuming they're like doing like.
You haven't seen the full solution, right? I mean, I don't know what's going on here, but I don't think you have seen everything. But you know, you can just evaluate the solution instead of guessing, because I think there's a next page or something like that. I feel maybe. I'm not sure. I'm not seeing your note. Is there another page?
No. This is the next page.
I cannot see the page. I cannot see. Yeah, definitely not. Yeah, definitely not. So this work example is half done. Am I correct?
Yeah.
Right. Now, can you please be comfortable with your question and simply list them as a question? Like, what's going on here? Can you please just put a question mark and move on? This is before the lecture, not after the lecture. Like the question mark probably should be there. I agree, and probably should be at where you were. Probably should be there. You know, like your question is like seriously, what's going on here, man? Something like that, right?
Yeah, but I feel like it's not it's not like how do I put this? It's not like a worthwhile use of my time, you know?
Because like what?
I feel because like like I feel like if I ignore this and I just did it like okay area under like here, so it'll be like that. Like area under here to this point. I draw a dotted line down here, so I find this area bounded by the two limit here minus the triangle. Then afterwards, I do this. Do the same thing.
For the bottom one, what will you do?
For bottom one, I guess it would be like that, right? Because like if I
no. I mean the bottom one according to the x-axis. Right?
I mean,
you should be treating them separately, right? Did you not treat them separately?
Why mean separately?
Just now you're referring to it from the x-axis perspective.
Yeah.
You didn't do it completely, you know. You only addressed the top of x-axis. You did not address the bottom.
I thought that's supposed to do. Like, the top you use x-axis, then like the bottom you use y, and that's how they get you,
The bottom is y, sorry, what?
Like the top, all this stuff here, you must use the x-axis, then
and then the bottom one?
To the bottom section, you must flip it to the y-axis, and that's why it's complicated,
Why do you can't you do both from the x-axis perspective first? Cannot? Really cannot?
I could.
Really? Why don't you at least try that?
Yeah, I guess I could.
So please try in your mind lah, because I see you describe the top one. That's nice. I don't mind that. Describe the bottom one, please.
Okay, following my previous train of thought.
Yes. How do you handle the bottom one?
So I could find the area bounded here, like the negative portion. But then once because
Okay, we have a lot of precious questions. Come, I will screenshot. Hands off, hands off. Thank you. You have your Jamboard?
I think it's right here.
Right. Have you made it for today?
No, not yet, because we haven't used it. Just make it now. Right, I've added you.
Right. Okay, I think the gem active. So I object on a few things. If it raises more question mark, you shall leave it as a question mark, right? And therefore, hope that the lecturer will address them. Remember, this is before lecture, not after. Yeah.
Okay.
The way you treat this is you need to focus on the limits. You know, you need to say I will integrate from this to that, right? And know that this is found here already. Like this is 4. I don't see you address that too much. I'm a bit bothered by it. And I don't notice you that you need to address yourself that you need to find this guy. And you do not consider whether you can or cannot. Can you find it for the sake of the triangle?
The top part.
No, this, yeah, for the top part. You need this point to find the triangle, ma? No way? You need what?
Yeah, isn't it like just 0? Like
can you find it? Okay, it can be found, eh? It can be found, eh? Okay, yeah. Good. So done lah. So this part is done, and this part is done in the first part. Now the bottom one. I'm a bit bothered that you don't just see it this way, a bit bothered. Maybe you're rusty. There. So integrate from here to here plus this triangle. Done.
Oh.
How can I do that? Is I focus very much on what you call the limits lah. It's just a natural limit. Hey, this shape, okay, I can natural limit, boom, boom, boom. Hey, wait, it works. This one you apply what you call the natural, it's a natural way of doing things. Oh, it's like that. I'll use this limit, this limit. Don't forget I have to use this triangle. Hey, that feels very natural. As the way that I feel this should be natural to you. Okay, okay? Okay, if you have some question on the x-axis method, you shall put that as a question mark right now. Do you have?
Using the x-axis meaning like turning it around.
Like just now we used the x-axis method, the one refer to the x-axis. We haven't used the y-axis one, which you assume that he's doing.
Okay. Let me see. Wait, let me just picture something. I need to think about this. Okay, but then like
you do not know that you know that point. Oh my goodness, Yankee. Okay, this part I do object.
Oh wait, isn't that the intersection?
Yeah. Oh for goodness. You do not pay enough attention on that. You don't. Frankly speaking, you don't put enough attention that, oh, I know this point, I don't know that point. You need those points for integration one. So that one I object a bit. I feel that is a very rusty part from you, which is good that we cover it today. Rather than in the lecture. In the lecture, you'll be very confused, or rather you will just, I don't know what you'll be thinking. So good. I think that's good. Okay. Are we clear about the x-axis method?
Yeah, I think so.
Okay. I will now, for the sake of saving time, formulate what I think is your question. Okay. I shall try to formulate it, see whether it rings correct to you or not. Okay. Your question is, why bother with the y-axis method if you can do it in the x-axis method? Is that what you are asking?
Yeah.
You write that
because
down.
Because here they make X a subject, so I see they're gonna do the.
Yeah. So you write that down. You write that down and wait for the lecture. Be comfortable, please. It takes us around 15 minutes to even discover or formulate this question. Better be worthwhile. I guess it's quite worthwhile. I guess it's not bad. I guess it's not bad. Please do that. Yeah, your handphone just do the weird thingy where it disappear. Yankin, can you hear me? Sorry, Yankin. Can you hear me, Yankin? Yankin. Right. Okay, I think you're muted, Yankin.
Hello?
Okay, good. Right. Then please write down your question or formulate it or do with it, and we should.
Sorry?
I just formulated the question. I'm guessing what your question is. You say, yeah, could you please write it down or, note it, that, so that we can be done with it. Okay, right. Okay, good. Okay, clear?
Okay.
Clear as in you have a question here, right?
Yeah.
You have. And the question is reasonably thought of already, reasonably. Right? Mm-hmm. And you should be at least reasonably satisfied with the preparation you do here. So tomorrow will be useful. In lecture, you will be definitely focusing on this book. Like, give me the answer to this. Right.
Okay.
Fair enough. Okay. Fair enough. Yeah. Right. Now, you note a lot of objection I gave you. There isn't much objection I gave you when you were reading the chemistry lecture note, like last time. Like the way you read the lecture note of math, agreeably, it is a very different subject. I object a lot, and I feel that you should pay attention to my objection. Right? The summary of my objection is this: the way you study math makes math harder, not easier for you. That's bad. It really makes it harder. Like, wait, for example, I shouldn't draw. I shouldn't draw, but I should discover the steps. That one, if you look back, I don't think it makes very good sense. Like, what does your sense of good and bad and right or wrong telling you? Does it tell you to not draw, or does it tell you to draw first?
Tells me to draw, I guess.
Again, your sense of right and wrong and good and bad is still quite alert right now. I know you're approaching the limit, but still quite alert, right?
I suppose.
Yeah. So why were you suppressing it? What happened?
I mean, like,
I was very surprised.
Second guessing, I guess. Because like it feels like I probably should be doing this, so.
And you should. In a sense that it's not that you should follow me. No. You should trust at least your sense of right and wrong and good and bad, at least when you're in your prime time, which is about right now. You should trust them and learn from their mistake, but they don't commit a lot of mistake during your prime time. Understand? If you don't use your sense of right and wrong and good and bad, instead of doing something, I feel it's a bit random. There must be a reason, but it feels random to me that you don't draw or you don't take the calculator immediately. I feel that you're following something else that is not very trustworthy or not very reliable. Therefore, how you learn math makes it more and more difficult without any merit. There is no merit in what you're doing, I feel. I feel that your sense of good and bad and right and wrong is reasonably trustworthy, at least on prime time. Okay? I'm praising or I'm affirming what you have. I think you have it. You should not ignore it or suppress it. Okay?
Yeah, okay.
Yeah. Okay. If you do it, you will discover, or at least I hope you're aware, you make math much harder than necessary, again, without any merit. Okay. Now, I will assign you to read maybe 1 or 2 more pages. I think that should be good enough for the lecture, right? Not right now, not right now. Right? Because you're supposed to read also your practical, right? Your physics practical.
Yeah, physics practical.
Can we shift to that? And I'm giving 10 minutes as a guideline, not as a pressure. Yeah? So please prepare and I'll just 10 minutes. Again, you should be very aware of your question. Please be aware of your sense of right and wrong and good and bad. 10 minutes.
I don't really know how to, prepare for this, but
yeah, like how do we prepare? What do we look for in a preparation? Tell me, what do we look for in preparation?
Questions?
Yes, not answers, questions, meaningful questions. Okay, ready?
I'll try.
10 minutes.
Oh dear. Okay, that's pretty simple. So, for resistance of wire A for the length L, by plotting, determine theory K. What's K? What? Oh, K is gradient. Also given by, really?
right? Why do you erase that?
Oh, I just wanted to, because like K is given by this, right? So that means R equals L equals to P go over A. So I just want to confirm. So I did R equals to.
Yeah, which is fine. As in, do you have to erase that?
And I guess not, but like, you know.
Yeah, don't erase it. Don't erase it, right? It's considered preparation. You can erase later, right? You can erase it later. You know, it might be useful, right? Might be useful. Right? Again, preparations are hard and fast, huh? Yeah. So do that. Good. Great.
Measure record diameter.
Not to pressure you, you still have 6 minutes left.
Yeah. Calculate the resistivity. Derive the SI units. What? SI units of resistivity. I mean, I could just look that up, but like,
Again, generate the highest quality questions, please, right? If doing something will improve that, then please do that lah. Right? You still have time, you know, like, you know,
yeah,
you're
but
reading
like,
of.
I mean, the question I had was just like, how do I do that? So, you know, I feel like I could answer it more.
All right, cool. Then, yeah, that's not okay. That's okay. That's okay. Right.
R is dependent on cross-sectional area. Measure B, why B is resistivity. Yeah, I assume it's cross-sectional area. So what's this?
Actually have almost 5 minutes left, right?
Oh,
yep.
Appendix A. Using a rheostat as a potential divider.
This is a very important. This will
take a while.
Please do.
Potential difference between B and A and C, and potential difference between what? Oh, okay. So like the two extremes. Null deflection, that means perfectly straight, right? So I find the position where there's null deflection, then I can determine the resistance of from here to here, or from here to here. Okay.
Be very aware of your question marks, if there is. Very aware, like your sense of right and wrong and good and bad should tell you certain question marks here, if there is.
I guess just understanding like how this works was
very vague question. The very vague question after 2 minutes of reading, and is a serious reading. I feel that you are seriously engaging with the paper, but
yeah.
The question doesn't seem to be very quality. I want you to improve that, right?
I don't know. I feel like a lot of practical questions are just like one step answers, you know, because the difficulty is in how I set it up, which is like
right. Okay, so you're sure that you don't have to worry, right?
It's why I put like stuff like this, like without connecting the battery to a circuit, measure the EMF. How do I do that?
A very good question. Yeah, very good question. Yep, that is a good question. That is something that you will surprisingly need during questions. I mean not practical. Surprisingly, you can do that. Surprisingly.
Yeah. Anyways, I guess I'll find out tomorrow.
Yeah, which is the spirit lah. That's the spirit. Oh, I'm gonna find out tomorrow. If I don't find out tomorrow, I'm not happy lah. I'm not happy. I think I should find out tomorrow. I think tomorrow should at least give me this value. If not, why bother with the practical, right?
Yeah.
And you haven't spent your 10 minutes. You haven't. So go ahead. You still have 1 minute left. 1 minute.
E and R, yes, right. It's just an equation. Yeah. So linear graph. Wait, is it? No, it's not. Wait, no, it is. Never mind. V and I, yeah. So all values of I, V, yeah, okay. Let's check the internal resistance of the battery.
Are you sure there are no more question marks?
I don't like. I feel like the question marks I would have would be regarding like the setup of the experiment and like how I should go about doing it.
Right.
That's like the main part of practical, right? And I don't see much in the way of question regarding how I should set something up beyond like the measure I call EMF from just now.
Right. Okay, and that was the 10 minutes, right? So you are reasonably okay with your preparation.
I hope so. Yeah.
Okay, let's see what happened tomorrow. I suppose, right? Okay. I at least in physics and chemistry, at least last time and today, just now, you're at least comfortable with your questions. You are at least you're comfortable reading an incomplete document, basically. You're comfortable with the questions, and that's just naturally. Therefore, you have some expectations of tomorrow. Naturally. I noticed that you are not comfortable with your reading of math, right? And therefore, your expectation on the math tuition is slightly here and there for now. Okay, that would be how you feel, I suppose. Yes.
Yeah.
Okay. You're almost. We are more than 1.5 hours, right? 1.5 hours. How is your sense of right and wrong and good and bad? That's the same question. Is how is your star right now? It's the same question.
I'm feeling. I'm not sure actually. Like, I'm thinking like probably going to be.
Is this difficult because it is no longer 3-star, or is this difficult because it's a difficult question? Which one is it?
I'm not sure where I am. Like energy wise, like I feel fine, but like that can change rapidly,
Yep.
I feel like a 3, but I could go down any moment,
Yeah, and I feel you shouldn't spend too much time anymore. I mean, as agreed, right? We should be stopping. I was never the one to put too much on quantity of studying. It should be the quality. Should be the quality. So you have some good and some not bad, yeah. Some less good. Still quite good for math, I would say. Still quite good.
Yeah.
Right? Okay. Now, tomorrow, that will be your last preparation night for the week, right? Because on Friday, we are useless. We should be resting or doing something else, right? Now, tomorrow's preparation, let's talk about that before we stop, right? Tomorrow's preparation should be on what?
Chem, physics, math. They're all 3 tutorials.
Whoa, crazy.
Yeah.
Okay, I have a challenge.
Yeah.
A challenge for you, right? So the preparation for the tutorial, whenever possible, starts during the lecture.
Really?
So we cover preparation for lecture. I mean, it's just basically this. You just have to improve on the way you read math, for example, right? But preparation for tutorial starts at lecture. In that sense that if the lecture is boring, I mean the good boring. What is a good boring lecture compared to a boring lecture?
I can get what they're saying. Yeah, I can get what they're saying quite quickly.
That's a good lecture, yeah. But the quickly, I suppose, is like, okay, paying attention on lecture is not sacred, suppose. When you, wait, I think I understand. During those times, do not pay attention too much. Do not. You might be reaping the fruits of your good preparation, the 10 minutes, the 15 minutes, the half an hour. You might be simply reaping that. You might be a good star. It might be that the topic is just suitable for you. Whenever that happens, take out your tutorial. Do something. For math, chem, and physics, you have examples interspersed in the lecture note, right? With. Either you do the tutorial or you do those examples. Either.
Right.
Do not simply pay attention to the teacher if you already know this is a positive boring. It's a good boring. I better do something with my time. Do it in class.
Okay. It's
obvious to me, at least, when I look at your lecture note, that the examples which is with inside, the difficulty increases with as we go towards the end of the lecture, right? Which, like the last example, is not easier. The last example, is not easier than the first tutorial question. Definitely not. The last work example is like about the level of maybe 75% of the tutorial, something like that, along that way. Okay, make sense?
Yeah.
So if you do that actively, your tutorial doing will be faster, like almost guaranteed. One more time, do things actively in your lecture time when the lecture is good boring. Do not just simply pay attention. Why? What for? Do your tutorial or do your work example. That will be your challenge for tomorrow. See how that affects your preparation later. Because, tomorrow night. Because to prepare for tutorial is simply to do it, right? I do it. Like, 15%, 50% before the tutorial, right?
Yeah.
Just be very comfortable with your question mark. When you try to do the tutorial, it is still like that. You should be a bit more aware of your question than your answers. It's not exam. It's not revision. Let's say you do 70% with a lot of question marks. Your tutorial class will be super compared to you do 30 or 40% but perfectly. Then the rest, the other 60%, which is probably harder than the 40% that you do, you have no question mark at all. Your tutorial will be very lopsided, boring, and then super difficult. Do you understand what I'm saying? It is better to cover more and have more question mark rather than just to cover some perfectly. Unless you cover the hardest part, which is like that's not going to happen, right? Make sense?
Yeah, I think so.
Try do that. So my 2 challenges to you is during lecture, make use of the good boring. I think you have some. Okay.
Right.
When you prepare for a tutorial, you have limited time. Remember, you do have limited time. It's better to generate questions than to just aim for answers. That is almost definitely true. That is a good preparation for your tutorial. Again, if I'm scamming you, you will know immediately. I won't be able to scam you for 1 year, right?
Yeah.
Have I been scamming you? I'm a, scam master.
I don't think so. Not yet.
Didn't teach you much, today, just scolding you, I object on this, I object on that. You suck at reading math, that's what I've been saying to you. Like, you suck here, you suck there. Must be scamming you. Ask you to read for 10 minutes, then I just sit there and watch, Maybe I'm watching YouTube, Are you sure I'm not scamming you?
I hope not.
Right. You will find out soon. Right? You'll find out soon. Okay. Again, what's my challenge for tomorrow? For you tomorrow.
Try and make use of the good point time.
During lecture, right?
And try to find as much questions as possible in the tutorials.
Yeah. Before the tutorial class.
Before tutorials, yeah.
Yeah. Okay. Right.
Right.
Last thing. Usually you're gonna meet on Monday night, right? Monday night happens to be my mom's birthday, and we cannot shift it because my mom will only arrive on my place on Monday night.
Yeah.
Can we shift to Sunday?
Like the Sunday before.
Supposed to be Monday, so this coming Sunday instead of this coming Monday.
Yeah, sure.
Right. Thank you very much. I'll send you the slots. You'll be seeing Austin also. Let's agree on the slot, and I'll see you on Sunday, that means we are preparing for Monday. That's not so bad.
Oh, one last thing.
Yes.
I'm finding that because today I'm supposed to CCA, but I start next week, right?
Sorry, I cannot hear you. Today what? Today? Sorry.
Today I'm the Wednesdays and Fridays are my CCA days.
Right. Yes.
So CCA ends at 7 and I get back.
Seriously, wow.
Okay. I get back. It takes me an hour to get back. So can I start 15 minutes later, so I can find to on Wednesdays.
So Wednesday will be a problem, right? That's what you're saying.
Yeah, I mean I'm not. I mean it's not as far wrong because I can just come back, then give me 15 minutes to prepare myself.
Right. No, let's try that. Let's just try once, right? And then we know immediately whether we should continue or not. Make sense?
Yeah, okay.
Just try once, because something like that, right?
Yeah, okay.
Okay. Next week, we won't be talking much more than the proper habit of preparation. We're already covering some, right? We won't be coming. I'll be interfering on your study method. We are still going to do, right? Right. That's what we can do at this point. And of course, the topics the topics won't be giving you too much of a problem, right? Not yet.
No, thank you.
I'll see you on Sunday.
Yep.
All right. Good job. Good job, Yang Kim. Bye.
Yeah. Okay. Bye-bye. Let me know time slot.